Good afternoon, everyone. I'll be talking about biology, crime, legal responsibility, neuroscience. I do have to tell you, I do not have a PhD in biology. I do not have a PhD in neuroscience, nor in social policy, and I have no legal qualification whatsoever. And actually, I would question the good judgment of the people who invited me here, that I actually be here and have something sensible to say to all of you. But having said that, what I'm going to do is make some outrageous statements about this area on responsibility and sentencing. First of all, though, I want to give you a little bit of data, and then we'll come to the issues of responsibility and sentencing. So I will first present a perspective on crime which is neurodevelopmental in nature. I'll then turn to one brain area you've heard about, the amygdala and fear conditioning. Then I'll turn to some odd areas of criminology research, and that's spouse abuse and white-collar crime, where the field may or may not be going to in the future. And then I'll turn in, having presented some data, on the issues of responsibility and sentencing. But first, let me talk about the possibility that recidivistic crime may be neurodevelopmental in nature. What's the basis for suggesting that? There's a neurodevelopmental condition called cavum septum pellucidum. You see it illustrated here. These two leaflets here are the septum pellucidum. So those two sheets of white matter, they separate the lateral ventricles of the brain. And during gestation, during pregnancy, all of us have a cavum or gap in between those two leaflets. Due to pressure from the development of the surrounding limbic system during fetal development, in normal people, those two leaflets will fuse before 6 months post-birth. So most of us will have a septum pellucidum looking like this. Others will have cavum septum pellucidum, reflecting maldevelopment of limbic circuitry, very generally. This is a marker for limbic maldevelopment very early on in life. We took 17 people with cavum septum pellucidum from the community, matched them to normal controls. The red bars are those with cavum septum pellucidum, and you see they have significantly higher scores on antisocial personality, the psychopathy checklist, more arrests, and more convictions. So the suggestion here is that early maldevelopment of this, quote, emotional limbic region of the brain may, quote, predispose to later antisocial psychopathic behavior. It is, of course, correlational. Nobody is manipulating the development of the limbic system, and nobody, frankly, ever will experimentally do this in humans. That's as much as I want to say, because that's a segue for tomorrow for the developmental session that we'll hear more about. I want to turn now to one structure within that limbic system called the amygdala, which you've heard about. We've done work on adult psychopaths, 27 of them, compared to 32 non-psychopaths, showing structural deformations in the amygdala. This is the amygdala here, and the blue indicates deformation in that specific part of the amygdala. The amygdala is a complex area. It's made up of 13 different nuclei. So when we map on the structural deformations in the amygdala, this is an example from the right amygdala, we see that maps on to the basolateral nucleus of the amygdala. There's actually 4 nuclei of the amygdala deformed in this specific group of adult psychopaths. What does this area of the amygdala do, as well as the central nucleus of the amygdala? It's critically involved in classical conditioning. But before I go on to classical conditioning, what we have here is a condition which you've heard about from Kent, psychopathy, a blunting of emotions, affect, no conscience, no remorse. And the, quotes, emotional region of the brain, the amygdala, is structurally deformed, or more specifically, there's an 18% volume reduction in the amygdala in these adult psychopaths. Correlational, cause-effect. We'll never get cause-effect relationships. However, we can get a step further to that by looking early on in life if individuals with a dysfunctional amygdala are more likely to grow up to become criminal psychopaths. What about 3-year-olds? What about 3-year-olds with a dysfunctional amygdala? Are they more likely to become criminal later on? Well, we haven't been able to do imaging on 3-year-old children. That's difficult. But what we've done is taken a marker for amygdala functioning fear conditioning and assessed that in a large sample of 3-year-old children. So we assessed autonomic fear conditioning in 1,800 3-year-old children. We then followed them up for 20 years, and we found that 137 of them, mostly male, had gone on to develop a criminal conviction. This is a case-control design, a 2-for-1 matching here of very carefully matched controls, matched on sex, ethnicity, and 9 indicators of social adversity at age 3. We then looked to see, do these groups differ? And if you're not familiar with fear conditioning, the CS plus is a neutral stimulus that predicts a future aversive event, if you like, a punisher. The CS minus is a control stimulus. On the y-axis, we're looking at electrodermal activity after the CS plus and before the UCS, the unconditional stimulus, the aversive event. To show better conditioning, you should show more electrodermal activity and translate that to sweat rate, if you wish, anticipatory fear, if you wish. The normal controls show fear conditioning, significantly bigger skin conductance responding to the stimulus that predicts the punishment compared to the control stimulus. But you see in the red bars, those 3-year-olds who go on to develop a criminal record simply fail to show fear conditioning. That is suggestive that dysfunction to the amygdala quite early on in life may be a risk factor for later criminal offending. Now, an editorial was written this is published in American Journal of Psychiatry, and Philippe Sturzer, the journal, published an editorial, Born to be Criminal. What do we make of findings like this? And what Sturzer argued is that, look, we've got to be extremely careful about data like these. You know, unless we're careful, these markers can be very easily misused and they could stigmatize individuals. And absolutely, we do not want innocent 3-year-old children to be stigmatized as future criminal offenders. Right? I think we might all agree on that. Sturzer then goes on the other hand, and talk about double-edged swords. Nevertheless, we have a wonderful opportunity here to understand more about the etiology of criminal behavior. And the last sentence in the editorial ran, so we should use this to benefit those kids at greatest risk of a criminal career and to design interventions that are tailored to their needs. Or do we? Or do we? Moral decision-making in psychopaths, just to let you know that we did a study on moral decision-making in psychopaths, putting psychopaths on less non-psychopathic individuals through a scanner when they were making moral decisions. And the results of that study, published about 2 years ago, showed that the psychopathic individuals show reduced activation of the amygdala when they are processing moral dilemmas compared to normal controls. So again, there's converging research suggesting, correlating reduced amygdala functioning with criminal psychopathic behavior. But how far are we willing to go on brain mechanisms and crime and as exculpatory factors? Let me turn to some areas of crime that we would not ascribe at all to neurobiology, I think. Spouse abuse. The feminine perspective on spouse abuse is that this is men controlling women deliberately, forcefully, in a proactively aggressive fashion to get what they want. We did a study on spouse abusers where we showed them mildly provocative stimuli, and what we showed in the spouse abusers, men who beat up their wives, is not reduced amygdala functioning, but significantly greater amygdala functioning. Red indicates in the contrast condition, spouse abusers versus controls, greater activation of the amygdala, quotes the emotion region of the brain, when presented with a mildly provocative stimulus, like an emotional word. And they have somewhat reduced frontal functioning. And so the suggestion here may be that, in addition to, other explanations of spouse abuse, could it be that some spouse abusers are emotionally overreactive to mildly provocative stimuli in the home context? White-collar crime. Be very careful here. These are under review, work not published, extremely provisional. that white-collar criminals compared to match controls, again, carefully matched criminal controls, show greater electrodermal orienting, higher physiological arousal, they have better executive functioning, they also have increased cortical thickness of the ventromedial region of the prefrontal cortex, increased cortical thickness. It's interesting it was in the anterior region here because the ventromedial prefrontal cortex is involved in encoding values onto reinforcers. Are they negative or positive? The posterior region, which did not differ in the white-collar criminals, is involved in reinforcers which are real and tangible, like pain, for example. But the anterior region of the ventromedial prefrontal cortex is involved in tagging reward values into abstract rewards. What are abstract rewards? One example is money. There's also increased cortical thickness in, you've heard it in the last talk, the temporoparietal region. White-collar criminals, do they have better theory of mind, better executive functioning, which can give them a heads up on some other offenders in perpetrating more sophisticated offences? Supposing research like that replicates and extends, do we ever want to have any type of brain excuse at all for people like spouse abusers or even white-collar criminals? Now to turn on to responsibility and sentencing, and this is the issue that, of course, you've been hearing about. If these neurobiological impairments do predispose, and we still don't really know cause-effect here, but to what extent are they fully responsible for their actions? You've already heard the case of Herbert Weinstein here, the man who strangled his wife in New York, threw her out of the apartment complex, I think 12 floors up in Manhattan. You know, he was caught, convicted, charged with first-degree homicide. Defendants brain scanned him, and yes, you don't have to be a neuroradiologist to see there's something wrong, there's something missing maybe. So, I mean, the issue here is that did come up, and he was found guilty of second degree in a plea bargaining prior to the trial. So yes, talk about showing a picture and the prosecution running away, that's just one clear example. But you know, what's the functional significance of a subarachnoid cyst? Many of them are very benign. What's the functional significance of any neurobiological impairment that may or may not be documented in offenders? Let me give you a quick example, you know, going back to case studies here. This is an individual I defended, rightly or wrongly. He had committed rape and homicide. He was in Denver, Colorado with a death penalty. We brain scanned him in the same brain scanner. We brain scanned 41 murderers. This is Donta Page. Donta Page is the defendant. This is the ventral prefrontal cortex. In the 63 normal controls averaged, you see significant activation there, which is distinctly lacking in the case of Donta Page. We didn't just rely on that in his defense. We put together a litany, which you can just read. I'm not going to read these out. Just documentation from the psychosocial record of the horrific upbringing that this individual had. 5 admissions to emergency hospital, raised in one of the worst US ghettos, seriously depressed at the age of 5 to 6. He was referred 8 times for treatment at school. They clearly saw this kid was out of it. Not once did he receive treatment. We put together, you know, frontal dysfunction, poor executive functions, teenage pregnancy, neglect, abuse, so on, and argued he's not fully responsible for his actions. The jury did not buy that at all. They found him guilty of first-degree deliberate murder. In Colorado, it's a 3-judge panel that decides the death penalty or not. They bought the package. And I think the point I want to make here is that my sense in the future is that it won't simply rest on neuroscience whatsoever. It's a complex mix of environmental, psychological, social, and neurobiological factors, and we have to increasingly take that into account into the future. So again, to wrap up here, just to give you those perspectives, I think the challenge I have and the questions I have is retribution. I mean, to what extent are they blamable? You don't punish someone if they can't be blamed. To what extent was Donta Page, who was once an innocent young baby, going through that horrific background, to what extent is he really fully blameworthy? Is it just deserts for him to have the death penalty? Deterrence, I've talked about poor fear conditioning, so You know, is there a deterrent effect in individuals who lack anticipatory fear? Psychopathic individuals. Of course, we must protect society. Question of treatable we've just had. I'm out of time, so we'll turn it over to our next speaker.